Hello friends and my dear students, as in the previous session we have discussed about the basics of forced vibration, okay, which is there in the unit 4 of your mechanical vibration curriculum of 3rd year 5th 4th 6th semester BTECH Mechanical Engineering of Rajasthan Technical University, okay. So today we will try to discuss what are the constant harmonic excitation, or what are the different steady and transient part, and how your frequency response curve will look like, and what are the rule of phase angle plot, okay. So that we will see. So let's go to that. So we stopped here where we got to know that vibration in the forced damped vibration is running system will never stop, means this vibration will be constant, means initially it is a component of CF and PI, and after some time this CF or complementary function is going to decrease 0, then PI will be constant, okay, and that will be continuous and constant vibration you will receive from this particular system. And that's why every mechanical system is having a running life, okay. And as we have also calculated this x, which is the solution for this real vibrating system, which will be equals to this particular function f0 divided by s sin omega t minus phi under root 1 minus omega by omega whole square to the whole square plus 2 zeta omega by omega n whole square. So, and this particular, if you will divide f0 by s by this particular term, means you just cut down or remove this sine term, then this will be your amplitude. This whole factor will be called as amplitude, means this solution is x is equals to a sin omega t minus phi. Now, as it is mentioned in your most of the exam, they used to call or take some questions on magnification factor. So basically magnification factor is the strength of the amplitude of forced vibration, okay, and the formula for this magnification factor is amplitude divided by f0 by s, okay. So in this way you can calculate the magnification factor. So if you will divide f0 by s to the a, then it will become as 1 upon 1 minus omega by omega n whole square into whole square plus 2 zeta omega by omega n. In some objective questions they used to ask that magnification factor depends on, then you can say it depends on omega by omega n inversely, and zeta, which is damping factor, which we have studied in the previous unit, okay. Now if I will say the whirling of the shaft, then you used to call, means that centrifugal force will be equals to that deflection or whatever the unit will come like m, which is m r omega square, m y plus e is eccentricity, so m r is y plus e, omega square is equals to sy. From here you can calculate the deflection, y is equals to e divided by omega n by omega whole square minus 1, and at when omega is equals to omega n, that at that point y will be equals to infinity, okay. So that you can recall, where if you sometimes they used to ask that how just try to derive the whirling of the shaft. I'm just recalling these terms quickly because whenever I will try to get in the deep, then it will take more time, and you can also recall it with the help of your books, okay. So now let's go to this particular calculation of phase angle excitation or phase angle calculations. Like after some time x is equals to a sin omega t minus phi, and if you will differentiate it or just take dx by dt, then it will be equals to x dot, which is equals to a omega cos omega t minus phi. Again, if you will again double integrate this particular term, then x double dot, which will be means this is your acceleration, x double dot is equals to minus a omega square sin omega t minus phi. It can also be rewritten as a omega square sin pi plus omega t minus phi, okay. Similarly, x dot can also be rewritten as a omega sin pi by 2 plus omega t minus phi. So we will see that this velocity is, as per as the phase angle calculation, it is forward in pi by 2 direction, pi by 2 phase angle, okay, while this acceleration is forward in pi angle in the phase plot, okay. So in this way you can also calculate or figure out these terms whenever you are plotting the frequency or phase plot, okay. General vibration equation will look like this: mx double dot plus cx dot plus sx is equals to f0 sin omega t, while these are the few forces which used to come in the picture, like f0 sin omega t minus ma omega square sin pi plus, because this is velocity, okay, this is your acceleration m into a, So you are just calculating inertia forces, which is F is equals to m into A. So m is this, or A, the value of A means that acceleration is A omega square sine pi plus omega t minus phi. So you have written it like this, minus Sx, okay, S the value of, this is Cx dot, okay. So here you have to write down the value of C, x dot is A omega, this value, okay. So in this way you can recall it, okay. And after that Sx is S and A the value of x is A sine omega t minus phi. So you have just kept the value of x here, x dot here, x double dot here, and you have taken all this term to the right hand side of the equation. That's why all the signs you can see here is negative, okay. That will be equals to 0. So this is called as unbalanced force, this is inertia force, and this is damping force, and this is your spring force. Now if you want to plot these curves, so just take the in consideration the phase angles, okay. First let's see, you have just plot the first unbalanced force, okay, which is F naught sine omega t, means at angle omega t this is F naught. After that you want to plot the inertia force, which is omega t minus phi, okay. So if we will come back with that phi angle, then this will become as omega t minus phi. So this is your Fi, which is m omega square A, or inertia force, okay. And just opposite to this, this is your spring force, okay, Sa, which this is also omega t minus phi. At the same angle you can see, because if this is omega t minus phi, then this also will become as omega t minus phi. Then this is your spring force. And after that, at angle means of omega t minus phi, sine omega t minus phi plus pi by 2, means if you will move pi by 2 from this direction and pi by 2 from this direction, either from inertia force or from spring force, then you will get the damping force value, which is C omega A, okay. Similarly you can also plot these curves with the help of this value, and your tan phi will be equals to C omega divided by S minus omega m omega square. It can also be rewritten as 2 zeta omega by omega n divided by 1 minus omega by omega n whole square. So this is your phase angle, which we are talking about in the syllabus. So this is all about your frequency curve graphs and solution, how you can rewrite, how you can plot these curves, and few numericals will also be asked on such kind of calculations. So just go through it, and if you have any kind of doubt, just do comment in the chat box of comment box of this particular video, okay. And we will also come with the next topic of vibration isolation and basic material for the vibration isolation and transmissibility in the upcoming topics or upcoming videos. So just stay tuned with this particular engineering college Banswara YouTube channel. If you have not subscribed it, just do subscribe and hit the like button if you like this content. And thank you so much for your patience hearing, and we will come with the next upcoming topic of different branches of engineering like mechanical, civil, electrical and computer science engineering. Thank you so much for your patience hearing. Thank you so much.